Hello, welcome everybody. So this is a brief little introduction on multiplying radical expressions that have square roots specifically. So let's start off with what a radical is. A radical is this symbol, and it's used to indicate a root. What is a root? So a root is sort of like the opposite of raising a number to an exponent. Rather than asking what is 5 times itself, 5 squared, the root is asking what number is the result of multiplying by itself. So in other words, the root of, let's say, 9 is going to be equal to 3 because we're asking what number multiplies to itself to give us 9. Now, technically, a radical can have different degrees, just like an exponent can be a higher number. For example, 5 to the third power is going to be 5 times 5 times 5. We can have a similar expression for the root. We would just put the number sort of in this little arm, tucked away here. So now this does not mean the same thing as this symbol without the number. If there's no number there, we just assume it's the square root, which is the opposite of squared. But if there's a number here like 3, then this is asking what number cubed is going to give us 27. So what number times itself again will give us 27. And that's still going to be 3 in this case. Okay, so that's sort of showing you what a radical is and what it looks like. It's just this little house-looking shape. And sometimes we put an n here just to say that a number occasionally goes there if there's a higher power root. We're not going to talk about any higher power roots today. We're just going to talk about working with square roots. And so this is what it looks like, just with the little house, the radical, and no number in the arm. We don't put a 2 here. You don't have to. Okay, so let's see how we multiply these expressions. Well, when we multiply radical expressions, we just need to follow some simple rules. We're going to multiply numbers that are outside of the radicals, just as you normally would, and then we're going to multiply numbers which are inside the radicals, just as you would normally multiply those numbers, but you need to keep the product inside the radical. Okay, you need to keep it inside the square root. Or when we work with other powers of the roots, then we'll just use the word radical. Let's look at an example. Oh, and matching square roots break free. Let's explain that really quickly. The reason why this is true is because if we have a square root of 2 and a square root of 2, you can multiply those inside of the radical, and now we can ask, what would multiply by itself to give us 4? Of course, this is 2. And therefore, whenever we have a square root of 2, you should think of the square root of 2 as, root of 2, the number which multiplies to itself and makes 2. So in other words, the square root of 2 is some number that if you multiplied it by itself, you would get 2. That's what the square root means. Therefore, if you multiply the square root of 2 times the square root of 2, that's multiplying it by itself, you just get 2. So in general, square root of any number times the square root of that same number is going to break free of the square root. That's what we mean here by square roots that match, they break free. So let's look at some tougher examples because these are really basic. Let's put some numbers in front of the radicals. For example, 2 square root of 8 times 3 square root of 5. Let's see how that works here. Well, that would give us 6 because we do 2 times 3. Those are the outside numbers. And then we multiply the inside numbers, 8 times 5, and we keep those inside the radical. This radical can be simplified more, but we'll save that for another lesson. For now, I just want you to be able to carry out the multiplication, and then later we'll work on some more advanced skills. Okay, so here's one for you to try. I'm going to give you negative 8 square root of 12 times negative 4 square root of 3. Let's see how you do with that. Go ahead and pause the video. Give yourself about 45 seconds to try it. Don't take too long. If you get stuck, you can just resume the video and we'll see how it goes. Okay, here we go. Now we're going to start with multiplying the outside numbers. That's negative 8 times negative 4, which gives us 32. Then we're going to carry out multiplication of the inside numbers, the numbers inside of the radical. And that's going to give us 36. Because 36 is a perfect square, we know that this is a number times itself. We can go ahead and just change this to be 32 times 6. Yeah, so I'm not going to show you how to really tediously break down radicals such as square root of 40 because that's not a perfect square, but it could still be broken down and simplified a bit. However, if we have any perfect squares, you should simplify those right away. It's a good way to practice what your perfect squares are. And so I encourage you to write down your perfect squares up to like, I don't know, see if you can go to 15. That's a great spot to be at. All right, one last one we're going to work with here. This is a little bit more challenging. We're going to multiply a binomial that involves a square root. So we're going to multiply 2 square root of 3 plus 5. We're going to multiply that binomial with 1 minus the square root of 3. Actually, let's call that a 4, just to make things a little interesting. Sorry, it's not written that nice. That's even a little worse, but at least the 4 looks nice. Okay, so let's carry this multiplication out. Don't forget how to FOIL. They're going to start mixing techniques when you're in Algebra 2. You're going to see a little bit of this mixed with a little bit of that. So it's really important to reinforce the connection between these topics like multiplying binomials and multiplying radicals, especially when it comes to preparing for something like a final, where you can guarantee that they're going to have all of these skills tested at once. So let's just carry out the FOIL process. And we have to be careful here because first we start off with 2 root 3 times 1, which is easy. Anything times 1 is just itself. But then we're multiplying 2 radical 3, 2 square root 3, times negative 4 square root 3. Don't forget that negative is there. And what is that going to give us? It's going to give us negative 8 square root of 9, because the radical 3 and the radical 3 multiply together. Okay, and now let's do the FOIL to distribute the 5. That shouldn't be too tough. Positive 5 going in there. So positive 5 times 1 is just positive 5. And then here, we don't have a radical number to multiply with the radical 3, so we're just going to multiply the outside numbers. Remember, this is a minus 4 square root of 3. And that's how you say it, by the way. You would say minus 4 or negative 4 square root of 3. This is going to give us negative 20 square root of 3. We're just multiplying the outside numbers. It's sort of like, if you really want to imagine the square root there, you can say it's like square root of 1 is there, which is just 1, if you really want to insist that there's a square root number attached. Now let's simplify if possible. This could be simplified because the square root of 9, that's a perfect square. That's just 3. And then what do we do with these radical expressions? We want to combine like terms at this stage. And you might remember that combining like terms requires the same variables with the same exponent slash radical. So it can't just be, x and square root of x. Those will not combine together with addition. Those are not like terms. But if we have something like this, where these are both kind of square root of 3 type, we can combine those together. So 2 minus 20 square root of 3 gives us negative 18 square root of 3. And then we combine the numbers. This is negative 24 plus 5 gives us minus 19. So that is the result. All right, so that was a little bit of a process to show you how exactly radicals are being multiplied. It's very simple, honestly. If they're the same radical, you just multiply the inside numbers together and you multiply the outside numbers together. Keep the outside numbers outside, keep the inside numbers inside, and remember that any matching square roots break free, which is sort of what happened with this square root 3 times square root 3. I could have just broken them free and called it 3 right away, but I did want to show you that there's a process for simplifying a perfect square root into a radical. Like I said, in the next video, we'll learn how to break down square roots such as this, square root of 40, and even other higher radicals such as cube roots, fourth roots, and so on. See you in the next one.